Okay, so solving radicals now. So previously we did rationals, now we're doing radicals. Now, the early ones are actually quite straightforward. Look, if I have this, 3x plus 1 inside a square root equals 4. Now, honestly, if I just square both sides, that's all I have to do. If I square both sides, it'll just leave me with what's inside the radical, okay? Just, here it is. Squared both sides. So that's the easy side. If I square the square root, kind of like it cancels each other, it's just 3x plus 1. If I square the 4, I get 16. So that's what happens when I square both sides, right there. Take away 1, divide by 3, x equals 5. There you go. You can check. Look, let's put it back into the original. 3 times 5 is 15, plus 1 is 16. The square root of 16 is 4. Okay, there you go. That's just checking, because it sometimes might not work. Let's have a look at one that actually does have one solution that doesn't work. Okay. Right, here we go. Now again, what you need to do is isolate the radical, okay? So what we're going to do here is take away 5 from both sides, do this, okay, and then this is what we are going to try and solve, okay? Now it's over here. Here's what they've done. Now again, just like the previous one, square both sides. Again, this is the easy. The left-hand side is the easy one. When I square the root x plus 7, it's just x plus 7. That's the easy bit. When I square x minus 5, okay, x minus 5 squared, remember, don't just square the x and square the negative 5. It is x minus 5 times another x minus 5, okay? When you do that, you'll end up with x squared minus 10x plus 25. Right, now it's just a question of getting everything onto one side, putting it equal to 0. It's a quadratic. So if I take away the x, take away an x to get negative 11x, take away the 7, take away the 7 from 25, get 18. Here it is. Okay, there we go. Now that will factor into x minus 9 and x minus 2. So the two solutions, the zeros, are x equals 9, x equals 2. Okay? Now, thing is check. I guess it doesn't really worth where we check really. Let's have a look. I'll go back up to here. Right, 9. What's 9 plus 7? 9 plus 7 is 16. The square root of 16 is 4. If we put the 9 here, what's 9 take away 5? That's 4. That works. Okay? In fact, let's have a quick look down below. Nope. Okay, I'll do the checking. Okay, so x equals 2. Let's put 2 into here. 2 plus 7 is 9. The square root of 9 is 3. But look, 2 here, 2 minus 5 is negative 3. Ooh, no. So this one does not work. It's just x equals 9. Okay? Again, check. Especially with these square roots. Because think about it. Remember, you can't square root negatives. You've got to be careful what you can actually use inside a square root. Here we go. Okay, big one. Final big one. Now again, we must isolate the square root. Now we've got 2 of them. So let's isolate just one of them. Okay? And it doesn't matter which one we do. What they've done here is we're going to take away this one here. Take away root x plus 5 from the left-hand side, and I will end up with this here, okay? Right, so there it is. Now, I'm still going to square both sides. Now, again, the left-hand side is going to be fairly straightforward. When I square the root x minus 3, I just get x minus 3. That's the nice bit. But look, when I have to square this, here it is. Right. So, again, we don't just square the 4 and square the root x plus 5. It's like doing a FOIL, okay? It's a distributive law with a 4 minus root x plus 5 and another 4 minus root x plus 5. In fact, here it is, right here, okay? So I'm going to show you how they've got this here by squaring this. Right, here we go. 4 times 4. Okay, that's 16. Now watch this. 4 times negative root x plus 5 is just negative 4 root x plus 5. That's all I can write, okay? 4 times root x plus 5 and it's negative. But the inner is also negative 4 root x plus 5. Can you see? That's going to give me negative 8 root x plus 5. Negative 4, another negative 4, and here it is, negative 8. And, of course, finally, root x plus 5 times another root x plus 5. Well, that's just saying root x plus 5 squared. It's just x plus 5. Okay, so look at that carefully. Right, okay, now then, 16 add 5. Okay, just 16 and 5 at the end. That's where the 21's come from. We've got the x still here. We've still got the negative 8 root x plus 5 here. Now, x's cross off 1 on both sides. Okay. Okay, if I take away 21 from both sides, okay, that'll give me negative 24, and I've still got the negative 8 root x plus 5. So that's why I've got this line here, okay, through it. Now then, if I divide both sides by negative 8 to get rid of the negative 8 next to the root x plus 5, okay, divide both sides by negative 8, I'll end up with 3. Now, we're comfortably, hopefully, back to this one. Just square both sides. This is the nice bit now. Square the root x plus 5. I just get x plus 5. Square the 3. I get 9. Take away 5 from both sides, and x equals 4. You can go ahead and check it, but that's it. Okay?